The Zyben RSR. I'm giving you a bit of a softball choice this time because, to be realistic, compared to other planes of similar types that actually got built, such as the SR-71, the RSR isn't necessarily nuts, but it went through so many growing pains and so many bizarre takes on the idea to get to where it ended up, and then cancelled, that I think it still counts a little crazy. This is a Soviet project that was meant to be an advanced long-range Mach 3 strategic reconnaissance aircraft. The project got its start as just the RS in 1954. That was supposed to be a ramjet-powered supersonic strategic bomber. However, that design was proven to be impractical. It just wasn't going to work. So they tried a smaller derivative, the 2RS, which would achieve intercontinental range by being air-launched from a modified Tupolev Tu-95 bomber. That also didn't really work that well at all. And this is because the aircraft actually wouldn't have enough fuel to return to base if it was used on an intercontinental mission. It was also incapable of carrying a thermonuclear bomb, defeating its entire point. So they revised the design again, this time with the intention of the aircraft being able to take off from actual conventional runways, and they dubbed it the RSR. Instead of ramjets, which need air flowing through them in order to do anything, this new aircraft would use turbofans. And instead of being a bomber, it was to be a strategic reconnaissance aircraft. It was supposed to be primarily of aluminum construction, with a long circular section fuselage. Inside the fuselage would be a pressurized cabin for a single pilot. This new design was meant to cruise at greater than Mach 2, at a height of 20,000 meters or 65,600 feet, and have a range of 3,760 kilometers or 2,340 miles. It did technically have a prototype, but it wasn't the finalized design. This was called the NM-1, and that was constructed in 1957. It was intended for low-speed handling tests. It had a steel tube fuselage with duraluminum and plywood skinning. It didn't use turbofans, but turbojets, and it first flew on the 7th of April 1959. Those trials show that the maneuverability of the RSR might be a bit questionable, and that was concerning because they weren't sure how it would be able to avoid surface-to-air missiles otherwise. So they redesigned it again, this time calling it the R020, to make it more maneuverable at high altitude, and it was equipped with the more conventional Tumansky R11 turbojets, as the turbofans it was supposed to use weren't actually available. 5 of the prototype airframes actually wound up being nearly complete, simply awaiting their engines by April of 1961, and they planned to build 10 more, but that's when the Soviet premier at the time, Nikita Khrushchev, decided to cancel the program. The Messerschmitt P.1101. Germany had a lot of unbuilt concepts during World War II, and this one almost got to the prototype stage, and it's once again a bit of a softball choice because it isn't necessarily insane, and in many ways it's actually a lot more modern than plenty of other aircraft at the time. You've probably noticed already, but not only does this jet aircraft integrate the jet with the fuselage, but it's a variable sweep aircraft. It uses swept wings, and that's again a very modern take on a fighter aircraft, but the sweep of the wings was meant to be adjustable. The angle could be changed before flight, depending on the situation. The design would later influence a lot of modern aircraft, even though it would never actually get off the ground itself. It was first envisioned specifically for the emergency fighter program, the same program the HE-162 was built for. Not only were the wings and engine placement very forward-thinking, but so was the cockpit, as the canopy was also integrated into the fuselage and formed part of the rounded nose, another modern take on a jet aircraft. By the time World War II came to a close and the Americans came upon the prototype, it was about 80% complete. It actually became a popular prop for GI souvenir photos. American forces removed the prototype from the tunnel where it was hidden, and all associated documents were seized. The prototype was shipped first to Wright-Patterson Air Force Base, and then it wound up at Bell Aircraft Works in Buffalo, New York in 1948. That's where the Allison J-35 engine was attached to it. but damage to the prototype actually ruled out any possibility of repair, although many of the design features went into the Bell X-5, which was completed, and it was the first aircraft capable of varying its wing geometry while in flight. So in a weird way, the P-1101 did wind up getting built, just not by the people who first designed it. The Convair Submersible Seaplane. We all live in an underwater plane, underwater plane, underwater plane. We all okay, I'll stop. And now we're getting into some really crazy stuff, which I'm sure you figured as this list descended into madness. Sometimes called a subplane, this concept actually has been drawn up by multiple sources over the years, from the UK to the Soviets to Convair. This is actually a US Navy project to produce a seaplane which could travel underwater as well as fly. It could just do everything. Put tank treads on it while you're at it too. Let it be a tank. Why not? It could do anything. Magical. This is clearly a G.I. Joe vehicle is what I'm trying to say. The contract was granted to Convair sometime in the early 60s. Sources actually dispute whether it was 1962 or 1964, but it was around there. It was intended for anti-submarine warfare. The idea was that it would be able to scout for enemy submarines from the air, and when they detected one, they would land in the water, submerge, and engage the enemy. The design parameters that Convair had actually had a fairly slow aircraft for that time, only being able to fly about 220 miles per hour, or 350 kilometers per hour. It would also have an underwater performance up to 10 knots, or 19 kilometers per hour, and a depth of about 75 feet, 23 meters. It would be able to do all of this stuff for about 10 hours. Convair's take on it would have been a flying boat, not a float plane, which is a little bit different. And it would be powered by 3 turbojets with a crew of 2. It would also carry a payload of up to 1,500 pounds, 680 kilograms. It would use ballast tanks to dive and surface like a conventional submarine, and those would be located in the wings and in the fuselage. It wouldn't have any air-to-air ability. The weaponry was to be torpedoes or mines, and for undersea operations the turbojets would be sealed watertight, and underwater propulsion would be provided by a battery-powered electric motor that would drive a propeller. Convair did build scale models that were tested, and it showed that it could work, but the project didn't get beyond that. It was canceled by Congress sometime in 1965, or 1966, again, depends on who you ask. And to be honest, looking at it, I'm not sure how well it would have gone as an effective weapon. I mean, maybe this is just me, but for one thing, if it could fly, not having any air-to-air capability and being that slow would have made it pretty vulnerable to attacks by anything other than a submarine. Also, if it could detect submarines from the air, why not just have it drop depth charges? I mean, that's what modern aircraft do when they detect a submarine in warfare, and that seems to work just fine. You don't have to go through the hassle of landing in the open ocean, submerging, and then attacking the submarine. Just do it from the sky like a normal person. This project would have been very expensive, and I question the point of it. As cool as it may have been, though, because I will stress that. The idea of a plane that could also be a submarine, yeah, that's pretty awesome, not gonna lie. I just don't think there was a point to it. The Boeing X-20 Dinosaur. You called it the Dinosaur? I'm so happy with that name, you have no idea. But, in this instance, Dinosaur was short for Dynamic Soarer, and it was a United States Air Force program that was meant to develop a space plane. Yes! Space planes are something that has been historically sought after for many years, and there's been very few examples of truly successful ones. The only ones that have been able to do everything a space plane does has been the Space Shuttle, the Soviets' Buran, and the X-37. The most successful out of those three, of course, being the famous Space Shuttle. But even before that, Boeing and the Air Force were looking at another take on the concept. And I think there are many avenues of growth that the space plane concept has here. I mean, the idea of an aircraft that can fly and then simply go into space has been well and truly in the realm of science fiction for a long time. I mean, just consider stuff like Star Wars or Star Trek. Many of the aircraft in both those mediums have been shown to be able to travel in the atmosphere of planets and go into space. We've been trying to do the same thing for years with limited success, and the Dinosaur is one of the earliest attempts at it. The program was officially started on October 24th, 1957, and it ran to December 10th, 1963. It cost the US $660 million of research funding. In modern money, that's $5.84 billion, but I'm gonna be real with you people, whenever we're putting money into science and space and things like that, I have no complaints. I actually encourage money to be blown on that sort of thing, because at least even if the project fails, we learn something that can help in many other avenues of life. People often don't realize how much the space program has influenced our day-to-day lives. From the creation of new materials to new inventions and things like that, reaching for the stars does have an effect on the quality of life of regular people, even if you don't see it. And I do think it's kind of where humanity needs to go next. This planet won't last forever. If our species is going to survive, we must reach for the stars. And I really just want to get off this rock. Have you seen this place lately? I'm out. But back to the Dinosaur. As an early take on a space plane, well, it was like a plane. It looked like a plane. That made it very, very dissimilar from space capsules at the time. Because, well, they were space capsules. Mercury and Vostok were both simply orbital capsules that could be somewhat maneuvered, but would then land under parachute. The Dinosaur was meant to be able to fly, as well as go into space, and then return to Earth and land at an airfield just as the space shuttle did. It was bold and much more advanced as a concept than other human spaceflight missions of the same time period. And it even did get to the mock-up stage, but it never actually flew. Certain components were tested, some were flown and tested on other aircraft, but the X-20 itself, even as a prototype, never actually took to the air. The reason is that there were many problems with the idea, especially back then. Like I said, this was incredibly ambitious, and for one thing, it would have been violently expensive. Building a space plane now is expensive, let alone back in the 60s. But cost really wasn't a deciding factor with this thing, because at the time, the US government saw fit to throw just all the money in the universe at the space race, because they had to beat those dastardly communists! And it would be certainly nice if the land of the free would have a space plane, while the Soviets were still fiddling around with capsules. No, it was issues over the booster to be used, as well as the clear lack of a reason for the project. There were plenty of boosters that could launch it, all of which were proposed with various upper stage and booster combinations, but the Air Force couldn't figure out which one they really wanted. It took so long for them to decide that it really delayed the project badly and complicated the planning of it. Then they had to deal with their reasoning. For one thing, it was debated whether or not the US Air Force should even be fiddling with space at all, because some thought that this should be the primary domain of NASA. The Air Force's main argument was that not only would this project allow for controlled re-entry and therefore fly like a plane, but also it was kind of a military project. And NASA wasn't completely a military organization. Their main focus was science, not necessarily military applications. Though it's been debated that they may have been involved in some military missions in the past, and certainly have a close working relationship with military organizations like the United States Air Force. But coupled with the projects that NASA was working on, like Gemini, the Dinosaur didn't really seem that, well, reasonable. Why put all the money into this when we could focus on one thing at a time? Some of the top brass thought that the project was trying to run before it could walk. Gemini was a lot more reasonable, using more familiar technology. It was still pushing the envelope, but not as hard as the X-20 would. And in order to maintain their sovereignty over their project, the Air Force had been placing a lot of emphasis on the controlled re-entry aspect, and they didn't actually have any real objectives for orbital flight, which is kind of a big part of being a space plane. Couple all this with the expense, and the fact that it wouldn't actually be ready for launch until at least the mid-60s, and that was at the earliest, it meant that the Air Force just couldn't justify the program, and it was cancelled on December 10th, 1963. the Lockheed CL-1201. Oh boy, now we're getting into some real nonsense, some real crazy, unspeakable madness. There's no competition for this absolute display of, well, I'm gonna kindly say imagination. But I'm also going to point out that whoever imagined this was out of their mind. This was a design study by Lockheed that was carried out in the late 1960s, and it was supposed to be an airborne aircraft carrier. There are plenty of concepts for airborne aircraft carriers that have been done over the years, and it's a pretty hard thing to pull off, though the utility of having an effective one is certainly something the militaries all over the world have looked at. But the CL-1201, even in this vein, was out of control. It would have a wingspan of 1,120 feet, 340 meters. That would be the largest span of any airplane to date, even now, and more than twice that of any in the 20th century. The wing would be crescent-shaped. It could carry up to 22 fighter aircraft externally, and would have an internal dock capable of handling 2 air-to-ground shuttle transport aircraft. It also had a logistics support variant that could have a conventional heavy transport role. But how was such a gargantuan beast that was estimated to weigh at least 11.85 million pounds, or 5,375 metric tons, supposed to stay in the air? Well, that's easy. It was going to be nuclear-powered! I mean, duh! If you're gonna make a giant nonsense plane, why would you not, therefore, install nuclear reactors? Also, in order to get airborne in the first place, it couldn't just use its onboard power. Nah, it would need 182 additional vertical lift engines, because, yeah, why not? This whole thing is well and truly insane. However, rather cool, I must admit. And if you're gonna make an airborne aircraft carrier, making it nuclear powered and therefore capable of staying in the air for multiple days at a time kinda makes sense. Part of the reason why aircraft carriers are so effective is not only can they go all over the place, but they can stay in that place and then move around, and then stay in another place, and then move around, all without needing to be refueled. An airplane needs to stop and get fuel fairly frequently. You would need something that could, well, not do that. And nuclear power is really the only way to reasonably currently achieve that at this time. Or back then, for that matter. But is using nuclear power in the sky reasonable, especially when it's such a large, rather easily targetable aircraft that has gone beyond the point of being a plane, and I know I've said this before, but I'll say it again, it is now effectively an ace combat boss? Well, the answer is, no. No, it's not. There's a reason why this was only a design study. The Air Force did not actually look into this seriously, as far as anybody knows, because... What? No, of course they didn't. I mean, good God. Would it have been cool? I mean, maybe. But reasonable? No, I don't think so. Will we ever see anything like it in the future? I doubt it. Not as long as it has to use nuclear power anyway. If they could somehow work out getting solar power to work on a plane, I might be able to envision something like this then. But putting nuclear power in the sky has always been a really, really, really difficult subject with people. And with me included. It's just too dangerous. On a boat or a sub, that's one thing. But in the sky, where it could land anywhere if something goes wrong? No, that's not. The Aerocon-1.6 Wingship. I'm just gonna call it the Aerocon, because that's a name. This, well, aircraft sort of deal really only barely counts as a proper airplane. Because it really isn't. It's a ground effect vehicle. But on what other list am I ever going to put this thing? And it still counts as a fixed wing craft. Some people call them chronoplanes. You're probably familiar with the Caspian Sea monster the Soviets built. That thing was enormous. And the United States also looked into the possibility of utilizing ground effect vehicle for multiple different purposes. Cargo transport, military roles, and possibly for passenger service. The thing about ground effect vehicles is that they can transport anything over very long distances at near aircraft speeds, but with a lot better efficiency. Their fuel consumption, for example, is usually lower than a traditional jet that would have to get well up into the sky. Ground effect vehicles stay in what's called the ground effect, which is the aerodynamic interaction between the moving wing and the surface below it. As a result, they fly, but only just above a surface, usually water, because you can do it over land, but you really shouldn't. There's a lot more things to hit, like the ground. This concept aircraft would have weighed 5,000 tons, but been able to carry about 1,400 tons worth of cargo, as well as 2,000 passengers, a distance of 11,500 miles. That's 8,500 kilometers. At speeds that would have been around the same of a traditional aircraft. DARPA actually looked into it, evaluating the design alongside other manufacturer proposals, as part of a preliminary study into the concept in general during the 1990s. They wanted to see if a billion-dollar program was necessarily viable. And thank you for checking. Actually, I appreciate that you're actually looking into whether or not it's a good idea before you throw $1 billion out there. I mean, I know we have it, but we shouldn't just throw it out willy-nilly, is what I'm trying to say. But by the end of 1994, the Department of Defense decided the design was just too risky, and didn't offer any further funding for it. Ground effect vehicles have similar weaknesses to that of hovercrafts. They're both very fast, and sometimes more efficient than traditional planes, but they're also at the mercy of the water. A ground effect vehicle needs the seas to be pretty calm, and they also can't turn very well. They also generally can't maintain proper flight. So in an emergency, they can't pull up. They would have to land back down in the water. And in a storm, that's not good. That's probably bad. And that's the reason why ground effect vehicles, to date, still haven't been used at any real capacities. Not significantly, anyway. The Conroy Virtus. What the heck is that thing supposed to be? That's the space shuttle. Oh, okay. So understand this thing was huge. This proposed design was submitted in 1974 by John M. Conroy of the Turbo 3 Corporation. It was to utilize two Boeing B-52 Stratofortress fuselages to form a completely new aircraft using existing parts as a cost-saving measure. What possible purpose was this for? Why would we need an aircraft that large? Well, it was seriously considered because, well, there's a reason the space shuttle's in the picture. This thing was supposed to move the space shuttle. That was the intention. They needed a very large aircraft specifically to move the space shuttle around. You're probably well aware that they wound up using a modified 747 with the space shuttle on top of it to move it around instead. But before that, the Virtus was considered. Back then, the space shuttle was actually originally designed to use turbofan engines for propulsion within the atmosphere on re-entry, rather than just gliding effectively, which is what it actually wound up doing. With that configuration, it could have taken off from a regular runway and moved itself around normally, without the need to be carried by a larger aircraft. But when those plans were altered due to cost and weight concerns, they needed something to move it. John M. Conroy, by the way, was the one who developed the Pregnant Guppy and the Super Guppy, two crazy but successful aircraft that NASA had found significant use with. Virtus is what he came up with, and it was expected to cost, at the time, $12.5 million each. That's a little over $52 million in today's money. The design called for 4 large jet engines, which were intended to be the Pratt & Whitney JT9D, which were used for the Boeing 747. As I said before, Conroy's design took into account using a lot of pre-existing components to try to keep cost at an absolute minimum, which might explain why he estimated the rather low price tag. The shuttle would be carried underneath the center section of the aircraft's wing, between the fuselages, and it was large enough that it could also carry other things associated with the shuttle, like the external tank or the solid rocket boosters. The design did get as far as wind tunnel tests, which were pretty promising, but there were significant drawbacks with it. Even though it was designed to be as cheap as possible because of the off-the-shelf components, it was still going to be expensive. Just the development costs alone for a new aircraft were going to be pretty high, and they knew that. Flight tests would have to be done, and that would take up a lot of time, and the sheer size of it would mean that they would need to expand infrastructure in order to support it at all. Conroy did not give up on the Virtus, though. He actually proposed a commercial version of the design, which he named Colossus. But it attracted no interest, probably for the same reasons I already mentioned. It's just too big. You'd have to redesign the airports around this specific aircraft, and no one wanted to absorb the tremendous cost of doing that. Though I admit, it would have been cool. The Boeing 2707. What the heck is that? That looks... Wait a minute. Yep, this was the chosen design for the American supersonic airliner. During the 1960s, every major country was trying to build a supersonic airliner. Only the Soviets, as well as the combination of the UK and France, wound up completing the project. But as you might imagine, America certainly wasn't willing to be left out of this because we have to be better than everybody else at absolutely everything. It's a rule that we stick to, except when we don't. But we don't talk about when we don't because this is the land of the free. And at the time, we were pushing to develop our own supersonic airliner. Boeing won the contract and began development at its facilities in Seattle, Washington. They were actually in the process of completing 2 prototypes when the whole thing was cancelled in 1971. But why? Well, the initial design actually called for a swing wing design, but that would have been really expensive. The required weight and size of that mechanism caused a lot of hiccups with the project, so they had to go with a more conservative delta wing design. Still, it could have worked. After all, the Concorde wound up pretty good, all things considered. But there were other issues with supersonic airliners that were causing concerns. See, one of the biggest problems with supersonic is the sonic boom. Aircraft that break the sound barrier cause a tremendously loud boom that can be heard for miles. Military aircraft get away with this, but for a commercial airline that's going to be generally flying over civilian territory a lot more often, that can start to get annoying. The Concorde wound up restricted to only flying over water for the most part. Even though the 2707 could have made the trip between New York and Los Angeles in a vastly shorter amount of time than a conventional plane, it never would have been allowed to because of noise complaints. There was also political issues surrounding it, mostly that the project was, of course, violently expensive, and many politicians said that it was frivolous federal spending. Which, I'm sorry, this is frivolous spending? Look, I live here, I know what you spend money on. This wasn't that frivolous. You shush, go back to arguing about something mundane, please. Either way, the funding wound up being cancelled, and without that, Boeing, of course, couldn't actually complete it. The prototypes that were in progress wound up being scrapped. And due to the loss of the contract, as well as a few others, it caused a significant hit to the American economy in the area. Boeing had to reduce its employees by more than 60,000, and the 2707 became known as the airplane that almost ate Seattle, due to the mass layoffs and so many people moving away from the city, trying to find work. You know, people on Facebook and Twitter always argue, why are we spending so much money on this project or this project? I mean, it's not really helping us, why aren't we helping us? But do you have any idea how many people have jobs because of ridiculous nonsense like this? Like, the advancement of technology is a job creator. Thousands, tens of thousands, possibly millions of people in the supply chain depend on it for their own financial security. And whenever cuts like this happen, sometimes it makes sense to do it, but it hurts people. And no one really thinks about that. And Boeing was really pushing the envelope. A lot of the design proposals in the original draft are actually kind of standard now, such as the glass cockpit it was supposed to use, as well as the supercritical wing. Though the prototypes were scrapped, the mock-up they built was actually sold to a museum. In early 2013, it was finally moved back to Seattle, where it's undergoing restoration at the Museum of Flight. The DFW R3. Now, this probably doesn't look like much to a lot of you, but I need to clarify a few things about this. DFW stands for Deutsche Flugzeugwerk. They were a German aircraft manufacturer of the early 20th century. This was a World War I aircraft, and it was designed to be a bomber. It was very, very similar to its preceding cousins, the R1 and the R2. But the reason why the R3 in particular is very notable as a thing that might have been built is how large it was supposed to be. Mind you, it was 1918. planes were still in their infancy. And large planes, very large planes like we have now, are rather commonplace all things considered, were pretty much unheard of. The reason I bring this up is this thing's wingspan was supposed to be 53.5 meters. That's 175 feet 6 inches. What? In 1918? Are you sure? Just for reference and clarification as to how big this thing would have been, the B-52H has a wingspan of 185 feet 0 inches. That's 56.4 meters. The R-3 would have had a wingspan only 10 feet shorter than the modern version of a B-52. In 1918! How was this thing ever going to get off the ground? Oh, you know, with 8 engines. Each one would have been 260 horsepower, Mercedes D4s. But this thing wound up never actually being built, because, no. Given how big it was supposed to be, coupled with the power output of the engines, I feel like most of their power would be used just to get this behemoth in the air. I'm not sure how much ordnance it really could have carried as a bomber. The R-2, the predecessor to this thing, was also pretty big, though not nearly this massive, and it was unsuitable for combat. They didn't use it for that purpose. That being said, I kind of still would like to have seen a picture of a completed version of this thing, just to say, look, it was the year 1918, and they were just 10 feet short of a B-52. Why? The Victory Bomber! What a nice, positive ally name. And yes, that's pretty accurate. This was a British concept during the Second World War. It was proposed by British inventor and aircraft designer Barnes Wallis while he was working at Vickers Armstrong. It was meant to be a large, very large, strategic bomber. And it was pretty ambitious for the 40s. It was supposed to have a wingspan of 172 feet, 52 meters, and it would have weighed over 100,000 pounds. It would be powered by 6 engines, and was designed very specifically to hit a speed of 352 miles per hour, 566 kilometers per hour, and have a maximum altitude of 45,000 feet. This was not meant to be a general all-purpose bomber. They wanted it to carry an earthquake bomb, a 22,000-pound earthquake bomb, to hit strategic targets in Germany. What the heck is an earthquake bomb? Well, to put it simply, it's kind of the ancestor of modern bunker buster bombs. Earthquake bombs were designed to fall from a great height so they could hit terminal velocity and puncture into the ground below, or the reinforced structure, and explode inside of it, rather than just exploding on impact. The concept was still in its infancy at the time, though it had been proven to be somewhat effective in certain applications. They're also sometimes called seismic bombs. But this bomb would have been way larger than any of the other earthquake bombs that were being developed and used at the time. And the RAF didn't have anything that could carry a bomb that weighed that much, nor did they have anything that could fly that high. Hence why the Victory Bomber was proposed, a unique aircraft that could meet the needs of this very powerful weapon. But it was rejected. Not because it wouldn't have worked. It may have, and it would have been interesting to see what the British came up with in the end. But even by design, it had some issues. For one thing, with technology that was available at the time, bombing from extremely high altitude just couldn't be accurate. And it's a little pointless to drop a bomb on a reinforced structure if it misses it. The idea was considered and studied greatly, even reaching wind tunnel tests, while the bomb itself was also being tested on representative models, but the Air Ministry decided not to proceed with it, terminating it in May of 1941. No prototypes of it would be built. Simply put, it didn't seem reasonable, especially at the time, to spend a great deal of money, time, and resources building a ginormous bomber just to carry one specific bomb. No matter how powerful the earthquake bomb may have been, building a bomber just for it didn't seem reasonable to the British Air Ministry at that point. Could it have been altered to carry other things? Sure, but the problem there was, how worth it is it for that earthquake bomb when they could just put more time and resources into building more Avro Lancasters? The Lancasters could drop more conventional bombs and do it pretty effectively. And they could also drop other smaller earthquake bombs like the Tall Boy, the Grand Slam, and the Bouncing Bomb. So if the Lancaster was already so flexible, why would they waste so much stuff for just a giant version of all that? It didn't make sense for them back then, and the thing was never built.